Now let's talk about one of the most well-known real-world examples of the application of exponential functions. That's called the compound interest example. Now, before we talk about compound interest, let's just make an observation about interest in general. So if we invest, let's say, $1,000 at year zero, so right now, with a 10% interest, then the idea is after the first year, we'll have $1,100. That's because we add 10% of our investment to our total. And then in year two, we'll make 10% on the $1,100 here. So we'll get 1,100, excuse me, not 1,000, but 1,100 times 0.1. So that's the amount of interest we'll get, which is $110. We'll add that to our investment, and on year two, we'll have $1,210. And the only thing I want to point out about this example is that with interest, the amount of money that we receive is based on a percentage of our money. And that sounds a lot like our description of exponential functions at the beginning of these videos. So that means probably to describe interest, you might need some information about exponential functions. Now let's talk a little bit more about compound interest. And I think this is best explained, compound interest, by just doing an example. So some of these definitions that I'm about to make, you won't know what they are, but I'll explain it through an example. So let's suppose we invest $1,000 at an annual interest rate of 10%, let's say for 5 years, and it's compounded once a year. And actually, I think I'll do a few different types of examples. First, when it's compounded once a year, and let's do two, once where it's compounded once a month. A few relevant definitions. This 1,000 that we invested is called the principal. This annual interest rate of 10% is called the annual percentage rate, or APR. It's also called the nominal rate. And what I want to explain is, what does it mean to be compounded yearly, once a year, and once a month? That is, what's actually happening to my money. After we explain what's happening to the money, we'll write down a formula and we'll use applications of the formula. Okay, so for part A, you start at year zero with $1,000. And much like our previous example, if you are compounding once a year, the bank is going to, or wherever you have this money invested, they're going to update your money at year one based on multiplying 1,000 by 10%. So they're going to give you 1,000 plus 0.1 times 1,000. So you'll have 1,100, and then in year two, you'll have 1,100 plus 10% times 1,100. So they're going to give you some more money, and you'll get 1,210. So that's exactly the same as what we talked about in the introduction. What does it mean now that if the bank compounds your money once a month? The main idea is what they're going to do is they're going to update your money not at year one, but month one. So we'll start again at year 0 with $1,000. Then they're going to update the amount of money you have at month 1. And the way that they do it is they take your old amount of money and they're going to add the interest rate times that amount of money. But they're not going to give you the amount of interest. This here is the amount of interest. They're not going to give you the interest amount for the whole year. Instead, they're going to take this and they're going to say, okay, we're not going to give you the money for the whole year. We're going to divide it by 12 because you have invested your money 1/12 as long as a year. So you'll end up with $1,008.33. And then they'll say, okay, in the second month, since we're compounding monthly, they're going to update your money 1 month after the first month, which is month 2. They're going to give you $1,008.33, the old money that you have, plus 0.1 times $1,008.33, and again divided by 12. And you'll have some new amount of money here. This turns out to be 1016.74, rounding to the nearest cent. And they would continue updating your money month to month using the same idea, taking the amount of money you had at the previous month, multiplying it by the 10%, or in decimal form 0.1, times the money you had at the previous month, and dividing that by 12. So now let's go back to our first example. What if you wanted to know the money that you had after 5 years? Well, you would continue doing this until you got to year 5, and you would have a certain amount here. In the example part B, you would continue doing this calculation month to month until you got to month 60, or in other words, year 5. Now, in practice, this is not what we do. We have a formula to shortcut this calculation. I'm sure you could imagine doing this calculation 60 times would be quite laborious. But the important thing is that you have an idea of what the bank is doing to calculate how much money you have by a certain time. So now that you have a basic idea of how compound interest works, let's take a look at a formula which shortcuts these calculations. So let's say that, let's call P the principal. Let's call R the nominal rate. And R here, one thing that is important for this formula is that it's in decimal form. So for example, if you're given an interest rate of 10%, R needs to be equal to 0.1. Let's say the money is compounded n times per year. And let's say it's compounded for t years, or invested for t years. Then the amount of money that you have, which we'll call A of t, amount of money after t years, will be equal to capital P times 1 plus R over n to the nt. Let's show how to use this in terms of the example that we had beforehand. So we invest $1,000 at an annual interest rate of 10% for 5 years, compounded. Let's skip the once a year and go straight to the once a month. So first, let's identify all of the symbols in our compound interest formula. So we have PR, T, and N. So P, the principal, is going to be 1,000. R, the rate, is going to be 0.1. N is going to be, we are compounding once a month, which means 12 times a year. So N is 12. And T is 5. Now, one thing I will note is that there is some terminology that is used in terms of the number of times it's compounded per year. So for example, quarterly would mean 4 times a year. Semi-annually would mean 2 times a year. Weekly would be 52 times a year. And of course, monthly is 12 times a year. Okay, so this identifies all of the information that we need for our formula. So the result after 5 years would be P 1 plus R over N to the NT. That's our formula. And this would be 1,000, 1 plus R is 0.1, N is 12, N again is 12, and T is 5. This results in an answer of 1645.31, rounding to the nearest cent. Make sure if you're using a calculator that you put 1 plus 0.1 over 12 in parentheses, and also if you're using a calculator you put 12 times 5 in parentheses. If in a calculator, in a scientific calculator, you do not put the parentheses, the calculator will think that you are saying do this to the 12th and then multiply the entire result by 5. It may be worth entering this into a calculator to make sure you get the same result as I got here, to make sure you have a basic understanding.